Over a single 10-day window in July 2026, 5 distinct frontier AI models dropped onto the market all at once. The industry treated it like a midsummer holiday. We saw the arrival of Meta's Muse Spark 1.1, xAI's Grok 4.5, OpenAI's GPT-5.6, and Anthropic's Fable 5 and Opus 4.8. This chart tracks the Artificial Analysis Intelligence Index. Independent data reveals a clear reality. The top models have effectively tied in raw intelligence. Zooming in on July, the variance is so narrow it functions as a rounding error, heavily dependent on the specific workload. Because raw reasoning is now a commodity, choosing your infrastructure based solely on which model is the smartest is a dead-end engineering strategy. The evaluation standard has to change. Engineers can no longer test models by firing single prompts into a chat window. The reality of production is managing multi-step autonomous loops, where models execute hundreds of consecutive actions. The singular metric that actually impacts an engineering budget today is your cost per successfully completed workflow. That metric is driven by 3 specific variables: how efficiently the model consumes tokens, how often it fails, and its recovery from errors. The central challenge for builders right now is finding the most cost-efficient architecture to execute complex tasks without introducing failures that break the entire pipeline. If we look closely at Anthropic, Fable 5, and Opus 4.8 represent the premium tier for complex zero-fail engineering tasks. Fable 5 dominates in executing deep research and multi-hour code migrations, but that reliability carries a highly prohibitive cost, running $10 per million input tokens. Opus 4.8 offers a different solution, introducing a native feature Anthropic calls dynamic workflows. Here, the model independently breaks a task into subagents, pushing outputs through strict verification gates, then stitching the work back together. Notice those gates locking in. The trade-off? You are entirely trusting Anthropic's internal verification loop rather than controlling your own custom harness. Anthropic is the necessary choice when a task failure is catastrophically expensive. But for high-volume routine operations, it is massive overkill. xAI took the exact opposite approach with Grok 4.5. They explicitly ignored the benchmark leaderboards to optimize for cost per task. They achieved this efficiency by stripping out native generation completely, restricting the 1.5 trillion parameter model to text and image inputs only. Workfill costs $11.80 on Fable 5, $5.07 on GPT 5.5, but exactly $2.49 on Grok 4.5. This Grok bar multiplies under the same ceiling, allowing developers to affordably brute force thousands of autonomous tool calls. xAI refined this model through a private beta in active industrial environments, heavily testing it at SpaceX and Tesla before releasing it to the public. For heavy, high-volume coding pipelines, Grok's extreme economic efficiency vastly outweighs its slight dip in general intelligence. OpenAI's GPT 5.6 slots in as the balanced enterprise solution designed specifically for teams deeply integrated into their ecosystem. The sole variant of the model runs on specialized Cerebrus hardware, allowing it to hit an output latency of up to 750 tokens per second. When your agentic loop has to execute hundreds of consecutive dependent tool calls where every step must finish before the next begins, that hyper-low latency becomes a mandatory requirement. Notably, GPT 5.6 had to clear a unique regulatory hurdle undergoing a 12-day voluntary national security review by the Commerce Department before it could be broadly released. It lacks the extreme cost savings of Grok, but OpenAI provides the safest middle ground for latency-sensitive enterprise deployments. Finally, we have Meta's Muse Spark 1.1. Despite early marketing hype suggesting it matched Anthropic in general reasoning, the benchmark trail tells a humbler story. It relies on a mixture of experts' architecture. By only activating a sparse handful of those experts per query, it achieves incredibly high token efficiency. Its true strengths lie outside pure text. It posts exceptional numbers in visual grounding, and its specialized medical reasoning far outpaces the competition. Meta is not yet the leader for heavy back-end coding, but that high token efficiency makes it a strong candidate for multimodal and vision-dependent experiments. Committing exclusively to a single AI provider is no longer a viable way to build. The new standard operating procedure for production builders is a concept known as model cascading. This network graph illustrates the mechanics of cascading. You route your high-volume, low-complexity steps down to cheap APIs, and you strictly reserve the expensive frontier models for the difficult bottlenecks. Architecting that specific routing logic is now the most critical skill for anyone building autonomous agents. This flowchart maps out the final decision matrix, starting directly with your task's complexity profile. If you are running multi-hour critical migrations and the budget is flexible, you route those directly to Fable 5. If you need high out-of-the-box reliability, but you do not want to code your own verification harness, route the task to Opus 48. For high-volume coding loops where your primary constraint is cost per task, Grok 45 is the clear choice. And finally, route to GPT-5.6 for balanced enterprise latency and Muse Spark for multimodal ecosystem integration. The best systems right now are not built by waiting for one perfect omnipotent model. They are built by orchestrating a resilient matrix of specialized, cost-effective tools.